Assalamu alaikum students. This is your teacher Miss Saima Khurram. So in the last lesson we were discussing regarding the allotropic forms. Now I was explaining you what basically are allotropic forms. So I gave you the example of the element carbon which occurs in different allotropic forms. Now what do you mean by different allotropic form? For example, when a particular element can exist in more than one state, more than one form, sorry, state is same, forms are different. In more than one forms in the same state, it is said to exhibit the property of allotropy, and the different forms that it is existing in are called allotropes or allotropic modifications. Okay, so to understand this phenomena better, I gave you the example of diamond and coal. Very common examples because we all have, if not seen exactly, somewhere we have seen the picture of diamond, and also we have seen coal in our daily life. So, diamond is a transparent, glittery jewelry stone that is used in the jewelry, very precious, very hard substance of the earth. Whereas coal, on the other hand, is a black substance which is very cheap, very readily available. Everyone can have it, used for fuel. So these two are not different; they are same elements, but only because of the different structural arrangement, their appearance is so different. So that I told you in the last lesson for the explanation of allotropic forms. So when we look at the different allotropic forms of carbon, we see that carbon exists in the crystalline form. Now, first of all, let me explain you what is crystalline form and what are amorphous form. Now, crystalline forms are those forms which have a definite, some specific geometrical shape. Okay, whereas when we talk about amorphous forms, so amorphous forms do not have any definite specific geometrical shape. They can occur in any shape. Okay, so that's how we have forms of carbon allotropic, and they are divided then into two categories, that is crystalline forms and then amorphous form. In crystalline forms we have diamond, graphite, and buckyballs, also known as fullerenes. Okay, now these allotropes, since they are nothing but the same element, their chemical properties are same, but because they have little bit of different arrangement in their structure, they have little bit difference in their physical properties. So in this we are going to be discussing regarding the over here you can see on the picture I have crystalline form of carbons. This one is the buckyballs fullerenes. This form was actually discovered very late. Earlier, we were only acquainted with diamond and the graphite, only these two forms. But later on, when more research was done or carried out, we got to know a new form which is called the fullerenes, Buckminster fullerenes or buckyballs in common. That is a relatively newer form of newer crystalline form of carbon. Okay. So in this we are going to be first dealing with diamond. Now it is one allotropic form which is the crystalline allotropic form. Okay. In diamond we have a structure like this. Okay. If you see the properties of it, it is colorless and transparent. Sometimes we have different colors like black diamond, like purple diamond, red diamond, and basically these colors are in the diamond because of some impurity in it. Okay, otherwise if you see the pure diamond, which is only carbon, typical carbon, that is colorless, that is transparent. Okay, also it is given the crown of the hardest substance in nature. Diamond does not conduct electricity. Why so? Because carbon in this is we over here we have the bond structure of it. In diamond, one carbon atom has its neighboring 4 carbon atoms. Now as you know already that carbon is in group number 4, which have got 4 valence shell. So all the 4 valence electrons, all the 4 electrons over here, as we can see, have bonded with the neighboring carbon atom. So this carbon basically does not have any free electron. Same is the case with this, same is the case with every other carbon atom in the structure. So basically carbon has no free electrons in its structure, and that is the reason it can't conduct electricity. Okay, because the conduction of electricity needs a carrier, basically an electron. Over here we have the properties as discussed, that diamond is the hardest substance, pure diamond is colorless. Now as I said, if it is having a little bit color in it, let's say champagne color, let's say red, black color, that is nothing but because of some sort of impurities in it. Its melting point is 3500 and it is a very high refractive index as given on the screen. Basically diamonds, as I said, are very expensive. They are used in jewelry. Also because of their hardest nature, they are also used for cutting glass and drilling in rocks. Let's move on to the other allotropic form, which is graphite. Now graphite is a dark grey color metal and it is soft and lighter than diamond. It is greasy. Also density is from 2.3 till 2.5 gram per centimeter cube. Okay, in graphite carbon atoms are arranged in layers upon one another. As you can see on page number 26, figure 2.2. So you can see that there are hexagonal layers and then there is dotted lines in between. Now this dotted line indicates the weak bond between the different layers, and that is why the graphite has a greasy structure. Graphite is a good conductor of electricity because in the structure of graphite, other than diamond, where all the 4 of the electrons of carbon were utilized, in graphite structure, one carbon atom will be bonded to the neighboring 3 carbon atom, and hence it will have 1 electron free, and because of this free electron, the graphite is able to conduct electricity, and hence it's a good conductor of electricity. Also graphite melting point is very, very high. Since graphite is slippery, it's a very good lubricant, and also graphite is grey in color and has a tendency to give a mark on the paper. It is used in making lead pencils. And as I said, because in graphite one carbon atom is bonded to neighboring 3 carbon atoms, the one free electron which is responsible for the conduction of electricity, and hence makes graphite suitable for becoming electrodes in many electrolytic processes. In the dry cell that we have, the central rod, if you have ever tried to open a dry cell, you will notice there is a central rod in between that is made up of graphite. Now on the screen you can see that there is a chart or tree diagram of the various allotropes of carbon. We'll inshallah tomorrow continue with the amorphous forms of carbon. Till then, Assalamu alaikum.